Hey everyone, welcome back to the channel. As you saw in my previous video, we discussed an Amazon online assessment problem, which was a relatively medium problem. Well, in this one, I'm going to discuss a relatively easier problem. And without wasting any further time, let's get started. So let's dive right into the problem. I'm just going to change the view. And yeah, so again, there was a lot of English in the problem statement, but I'm going to ditch that and just jump directly into what the problem is. Now, if you haven't taken a look at the problem, the previous problem that I discussed, I will pop a link that will appear somewhere on the top. Not sure where it will be, but yeah. Okay. All right. So let's dive right into this problem. So this problem has a lot of English. Quickly down to you have two lists, two arrays. Let's call the first one as A, second one as B. Both will have the same number of elements. Both will have same number of elements. Let's call that n. So let's say this has 1 comma 1 comma 2 and this has, let's say, 1 comma 2 comma 3. Okay, so now there is also another number given, that is m, which is the number of items we have to buy. So the problem is we have to buy m items in minimum cost. Okay, so the overall cost of buying m, how do we buy an item? I'll tell you. So cost of buying one item is a of I plus j minus into b of I, where j is the number of times you have bought the item of type I. Okay, so let's say we are buying a item of type 1. Let's say the indexing is 1 2 3 and we are buying an item of type 1 that will have the first item of type 1. So first item of type 1 will be 1 plus 1 minus 1 into b of 1 is 1, so it will be 1. Second item of type 1 will cost 1 plus 2 minus 1 into b of I, which is 1. So this will be 2 and so on. So we have to find out, let's say, for example, let's say m is equal to 4. We have to find out what will be the minimum cost of this. Now, to the keen observer, you can easily see that this question tells you, or maybe I'll just not tell you about that. So this is the problem statement. You are free to hit pause. Just like, just before hitting the pause again, just if you want to go over the constraints, n is up to 10 power 5. 1 m can also be up to 10 power 5. Okay, so this is the constraint that we have. Okay, and we have to solve the problem. Okay, so now is your time to hit pause, think about the problem, think about how you'll solve it, and then dive into the solution. And make sure you try this problem on your own first. Okay, so let's move on to the solution now. Okay. Okay, so if you look closely, I mean, when I look closely, this problem screams to be an arithmetic progression, right? So a of I plus n minus 1 into b of I. Doesn't this look like the nth term of an AP, which is a plus n minus 1 into d, the common difference, right? So basically, we have some of the starting terms of these APs and we have the common difference, and we have to keep track at every point. We have to find out the, so let's just write the AP. So the first AP will be 1 2 3 4 and so on. The second item AP will be 1 plus 2 3 plus 2 5 plus 2 7 and so on. The third AP will be 2, then 5, then 8, then 11 and so on. So if we were to buy, let's say, 4 items, we'll pick this one, we'll pick this one, we will pick this one, and then we can pick the minimum of these. So that will be 2. So we'll have 1 plus 1 plus 2 plus 2. So 2 plus 2, 4 plus 1. So 6 will be the minimum cost in this case to get m is equal to 4 items, right? So what is one data structure that can easily give me the minimum value that is present in the structure at any given point of time? Heap, right? Heap, also implemented as priority queue in C++ and Java, right? In Python, it's called heap queue. So this is the data structure, and this is the idea. So what we will do is, inside our priority queue, we'll insert, let's say, a tuple, something like the first term, comma, the common difference. A1, D1, A2, D2, A3, D3. All right. So we'll insert this. Okay. And then every time when we pop a value out, so let's say we pop A1, D1 out, we will put A1 plus D1, comma, D1. So basically, so pop the min, okay, and then after popping the minimum value, we put down, okay. So after popping the minimum value, we put down. So let's say we pop A1, D1. So it'll put A1 plus D1, comma, D1 back into the queue. So push this back, saying that we have used this particular term of this AP. Now push the next term of the AP. And every time we can extract the minimum and keep doing this m times, and we'll get the minimum cost. Easy, greedy, simple. N log n solution, n log m, right? So this will take linear time to insert everything, which is order of n. And after this, this is a separate query. So you run, so this will be n, and this will be m times you extract from the n elements. So you have m log n. So this is big O of n plus m log n. This is the overall time complexity of this problem, right? So yeah, let's get our hands dirty again. I'm gonna try to solve this in Java, and again, still getting my hands back on Java, so I might take a bit of time, but again, you have got the algorithm, you understand the problem now. Try to code this in your own language, and if you want to stick around to see how I code this in Java, you can hang around in the next section. So let's do that. All right, so we'll create a new, call it problem 2. Okay, what I will do here is I will create a main method quickly. I'll create a method called, let's say, static solve. I'll create a method called solve. This will return me an integer, which will be the total minimum cost. And solve will basically take the integer array A, the integer array B, and the number of terms that I want, which is m. Okay. So now what I want to do is I want to create a priority queue first. Okay, priority queue of, let's just say var queue equal to new priority queue of. So we want to insert a tuple. So again, we need to create a class for that, right? So I'll create a class. So let's say class tuple, or I'll say a pair. Let's say class pair. I'll call it, let's say, int first, int second, private. Let's create a constructor. Let's create getter. Okay. var queue new priority queue of type pair, right? And how do we want to compare this in pair? So comparator dot comparing int pair dot get first. Okay. So we want to do that. Can be replaced. Okay, replace this. I'll let it be like this then. So it will be, so let's say we return 0 for now, or we can specify int total cost equal to 0 and return total cost. Okay, so now for int I equal to 0, I less than a dot length I plus plus, we will do q dot add new pair of a of I, comma b of I. Okay, so we have put the tuple, the current term, and the common difference for that, right? So this is good. And then for int I equal to 0, I less than m, I plus plus, we will do total cost plus equal to q dot poll, what is this? Okay, q dot poll dot get first, and then we'll do q dot add, what is it say, replace with, and okay, it will not be null, but okay. And then we have q dot add, so we'll do first term, which is new pair of or maybe I should, yeah, I'll do one thing. I'll do a pair, or I'll do var current is equal to q dot poll. Okay, create this as pair, and the current dot get first, and then I'll do q dot add pair new current dot get first plus current dot get second, and I'll then do current dot get second. So extracted the minimum, added the common difference to that minimum, put it back into the priority queue. Keep doing this for m times, and we'll have the total cost. And that's it. That's pretty much it, right? So let's call this for a sample case. So we'll have solve of new int of what we'll put here. So the sample test case that we have was 112.123. 112.123, and the m is 4. Right, let's run this and see what the output is. Starting upgrade daemon. Okay, so the output is 6 as we expected, right? So we can run it for a really long amount of time. So we can, let's say we have to get 10,000 items. After 10,000, so very easy, and easily gives you the output, right? I would say this was an easy problem, but this idea to just to understand that it was AP and to be able to use heap was the highlight and the crux of this problem. Well, I hope you guys enjoyed solving this Amazon online assessment problem. If you did, make sure to give this video a thumbs up, and also subscribe to the channel if you haven't already. I'll see you guys in the next video. Until then, take care. Bye-bye.